Okay, for people joining this live stream, we are talking about machine learning functionality for our upcoming version 12.2. And we have a number of updates here, which I need to understand. Wait a minute.
Several of them you have worked in other meetings.
Yeah, I understand. This thing here, is this going into this version?
So I think array reduce, yes. Array insertion, I don't think so. I mean, no. But array reduce, yes. The BNU tried to improve it. So I did a top level version. So BNU tried to improve it, and his best efforts, he couldn't improve it, and he concluded that it was actually not a bad implementation, even though it's top level. So, okay. So I think there's no reason. I mean, we'll put it experimental, but there's no reason not to put it. And I think the design is good. And yeah.
Okay. Great. Well, that's going to take some knitting and things. Okay, let's just scan through what we've got here. Brian on our live stream is asking, what's the target date for 12.2? Well, the freeze for the code is today. The rest is your guess is as good as ours. I think it's my impression is that it's a reasonably solid freeze. Roger, do you want to comment on that?
I think most teams it's very solid. I think we'll you know, what I can speak for, what I see for sure, it should be shippable in a month. You know, so there's the tail of bugs now. Mm-hmm. And there's some things that I don't have insight into, you know, other teams. So I don't know exactly where they're coming in.
I'm most concerned about some front-end functionality.
Okay. And this is, when we do this freeze, that's when we get to see it all. And then it's when we start, you know, when we start to get a real picture of where we have.
And I'm supposed to give a keynote on Tuesday, I think. We'll summarize quite a bit of the stuff that's in 12.2, planned for 12.2. I don't know. That keynote, I would also, in principle, have to cover the 12.1 stuff. I think if I do that, those two together, it'll be like a 7-hour keynote.
Good luck with that, yeah.
We'll see how we handle that. Okay. All right. Let's see, method documentation. Okay, do we have that now here? Can I see the method documentation for dimension reduction?
You can probably see a few of them, yes. Like, I don't know, isomap or not sure if they've been linked yet.
So now you're looking at built. Okay, yes, that's okay. What are you running, Stephen? Is it?
It's the 12.2 from today.
Oh, okay, great.
But so what it should have up here is a little thing that says list of dimension reduction methods, right?
Mm-hmm.
They're linked below.
Normally they are linked. I don't think the link have been done yet. Normally they would be linked for each of them here, like we do for classify.
Do we do that for classify?
Yeah. It's really nice when they're linked, because then you go directly to the right page.
Well, no, I agree. I agree with that, but I mean, also, I'm expecting. Okay, here.
Yeah.
You know what? When we do this, given that we have these, okay, we should put that up here. List of classify methods. Actually, we don't even have a list. We don't have a separate guide page that has those on, which we probably should have. Yeah, I see what. Never mind. I'm confusing myself. I think we should have a separate guide page in future that has these on it and has these on it. Separate guide pages, and then we should do what we do. I mean, let me show you what import does, for example. Right, listing of formats. Boom, there it is. See what I'm saying?
Yeah. By the way, on the related topic of having links, NetTrain, remember some time ago, we moved all the application examples to tutorials. So now if you look at the examples and you go to application, you kind of find nothing. And actually there's no application, but the tutorials are excellent. Like if you look at a tutorial, and
let's have a scheme for putting the links in there. Let's say
exactly,
applications.
Yeah, I wonder what is the traffic on the tutorials, but I'm scared that it's not really well known. And there's a lot of effort that is done in doing good stuff there. As you see, it's pretty thorough.
Well, and the other problem is that
I think the people are trained to see applications here.
Right. So let's say applications, and let's have a scheme for the. If we could get Brian V in this meeting just for a moment, we could probably address this question right now.
I'll try to find him.
Okay. I think we should just say you open the applications and it says C. I mean, this is, C neural nets in the Wolfram language, which shouldn't be really a tutorial. It should be a monograph. That's what these were supposed to be. I don't think that. I thought tutorials have been discontinued as a type. Okay. All right. Let's keep going. Oh, graph and time series. I didn't know we could do graphs. Can we do graphs for, like, if I do feature space plot, will it deal with graphs?
It should be able to.
Wow, that's exciting.
There might still be a little bug there, but.
Okay, so where do I see that?
I didn't put. I can give you an example if you want.
No, I can do it myself. I'll do it myself. Let me do it myself.
Right.
I'll do it myself.
And Brian is here, Stephen.
Hi. Okay. Hi there. Okay, hold on one second.
I don't know if this is going to work so good if that hasn't been communicated to the Vis team.
Oh yes, exactly. So you have to do a labeling function right now. It has been communicated to Brett, and yeah, it should. It's just about reducing the size of the graph.
Oh,
that's beautiful. But
that's much better than I expected.
No, but this is the labeling function.
Right.
Yeah.
So Brett has to
yes.
put in labeling function. Can you make sure that Brett does that?
Yes. We can do
he's
that.
aware. He's aware.
It's just that I was worried that it isn't in place right now because this just came into.
Right. But also it shouldn't have the dots there, right? He knows that. Brett will know that.
Which dots?
These ones here.
Okay.
You just, the graph says where it is, basically. Okay, Brian, the issue here is we want to make sure that NetTrain, which currently has no application. Okay, first of all, why is this called tutorial?
Yeah, that's wrong. It just needs to get fixed.
Well, it says overview here.
Well, that is the overview. It's an overview of tech notes.
Of multiple tech notes.
It could be one tech note. Most of these are I think this happens to be multiple tech notes, but there are overviews that are linked into a single large tech note that happens.
Okay. So what we want to do is, and I don't know why that back button goes to the stupid wrong place. Down here under applications, okay, we want a type of thing that just says, C. Just say C neural networks in the Wolfram language as a link, right?
As a link, sure. Yeah.
Yeah. So just get that styled and put that in here. And I think we should be able to have both C and C also. In other words, in this particular case, we're taking all the applications out of here and putting them in that place. But in other cases, we can say C also, and then have some applications here. Does that make sense?
Yeah, that makes sense. That's fine.
Okay, great. Let Etienne know when you have that in place, so you can just add it to NetTrain.
Yeah, that's fine. I mean, there's certainly, it could just be added now. That should just pass through, but I assume you want it to be styled specially.
I want it to be styled, yes.
Yeah. Okay, that's fine.
I mean, I can put it in just as a stub. You want me to put it in as a stub?
You could, yeah, just under the application section, you could just put it could just be an example caption or something, some existing style that it should just pass through. But yeah, I mean, if you don't have to worry about it if it's going to be a thing to find it too.
I don't know why that pinked there. Why would that have pinked?
I don't
There's a
know.
lot of
Maybe it
weird
just needs to
stuff
be
here.
evaluated. Yeah.
Okay, all right. Okay, why don't you deal with it?
I'll just take care of it. It's fine. Yep.
Okay, okay. I think that's everything we needed. Thanks.
Oh yeah. All right. Great. Thanks. Bye.
Bye. Where's the time series stuff in here?
We didn't put an extractor, so I mean we named the extractor for graph features. We didn't name it for time series. Maybe we should. I mean, it was a. Yeah, we have to see if it's worth promoting it that much, because it was a bit naive. Timothy is improving it right now.
Okay, but I think you should mention that it works for. I mean, someplace here it says. Sounds. Good numerical,
I mean, there's
textual
so many,
sounds, images, graphs.
There's also entity, dates. I mean, a bunch of.
That's at least something. Now, are there other functions that need similar updates? I think there may be, right? Because then classify also can do these things.
All machine learning functions.
Okay. Can you take care of that, please?
Yeah. Okay.
Okay. Calibration control and measures. So where do I look here to see that?
So this is something. I mean, you can look in classifier measurements, and look at documentation of classifier measurements. Actually, that's a lot of things changed there, including the fact that it's a report that is returned now when you do classifier measurements instead of the classifier measurement object. I mean, it's still classifier measurement object, but it displays as a report.
Okay.
Thing that changed as well is that you can, use it without a classifier, and you can see the first example is with a classifier. I think the first scope example. Also, I just decided to change the scope to reflect. So I didn't finish, but to reflect the different type of measures you can do.
Yeah.
So if I, for example, open decision metrics. So that's something that people have been asking for a while, that you can use it without a classifier. So the first argument is just the list of classified data. And the second argument is a real classes. And
oh, there you go. You did add it.
Yeah, we did that with Roger. And
okay.
Exactly. You can see also there's a little paragraph. So it can be a list of class, it can be a list of probabilities, or a list of distribution, like a categorical distribution, which is like the.
Nice. So that looks good.
And so it returns this report, and which is something you agreed on quite some time ago, but I didn't do it yet. And the calibration, well, if you go in scope and you open the calibration, probability calibration section, you'll see the reliability diagram, which is basically the property that measures the.
Are we capitalizing these things?
Not sure.
Let's check consistency of that.
Yeah,
I'm not sure.
Yeah. The title probably, but maybe not.
Yeah, I think not
names.
The actual names of the axes. I should check that. Roger, by the way, what's happening with the actual development work on time series?
Oh, they were working on spatial, right? So we're there's just a bandwidth problem.
Okay. Oh, we should talk about that separately. Okay. Okay.
But we'll do that next. You know, there's a long list of things we know about, and we'll have some meetings, and so we can sweep up what are ambient requests.
Okay. I really like the spatial statistics stuff. It's really nice.
Good.
But I mean, so you know, the next thing there is spatial fields.
Yes.
I think
we'll do time, since you want the time series, we
probably
really
want time series. Yeah.
Do time series in between.
Well,
we should talk about the bandwidth situation there too, you and I.
Yeah, okay. I think we've got some possible ways to solve that.
Okay.
Okay. What am I looking at here? Documentation of methods.
Yeah, nothing much changed. It was a continuation of some change that were. I mean, I don't know if you saw that. It's like the updated. So there was still some method that we hadn't.
Yeah, I did see some of this. This is very nice.
Yeah, and we're trying to do the same thing for. I mean, we are doing the same thing for dimension reduction, which is a bit more tricky. You know, how do you visualize? I mean, it's basically feature space plot. So if you load, I don't know, isomap maybe. I forgot which one looked nice, but. If you look for the function page, I don't know, isomap maybe, or
isomap.
Find one. Yeah.
Why is it a function? It's not a function page, is it?
No, it's a method.
Yeah, I don't know even how to search for the method things. Okay.
I think
time series data type for this. Okay, supporting time series and sequence predict. That's really important. Okay.
Yeah. This one we're going.
You should have that as one of the basic examples of something in sequence, something as a time series.
Yeah. We're having a bit of trouble with that one.
Okay. MXNet backend update. That's a new version of MXNet.
And this is, oh dear. So the build of MXNet is some really nasty thing. And it has been done for CPU, and for GPU, release engineering has struggled to make it work. And honestly, I don't know we exchange a few emails. I don't know how to make that work.
Well, I mean, have you talked to Arnaud about it?
Not to Arnaud. I talked to Patrick Rice. Yeah, maybe I should talk to Arnaud and
I think you should
with him.
And the issue is NVIDIA GPUs, is that right? And is there some problem?
It's I don't know. It's a complicated thing, and they have a hard time to make a build that works. And and then now they tell us that it's a bit too late. And
come on, it's not too late.
Quite frustrated.
Okay. So the answer is you have to push.
Exactly.
Right? And if absolutely necessary, you can get me involved and I'll try and help understand what to do, or we'll get help from NVIDIA.
Yeah.
Right?
I think, Eventually, it should be us that do this build. So I mean, we have a plan. We had a plan to have new machines and things that RE could have a look on and, help us install things. But we would actually try to do the build and modify all the flags and do all the things ourselves. But this machine is not done yet. This environment is not set up yet. So I think when we have that, it should be smoother, because it has been quite a painful to have this build done. Which I understand. They say it's clearly the more complex library that they have.
Yes, I understand. But my point is, we can absolutely get NVIDIA to help us do this if we run into trouble that's related to building MXNet. I mean, if it's building our own software, it's one thing, but it's building a freaking library. It's it's not an issue type thing. Okay. New icons for NetGraph. Those are icons for the display of networks. Is that correct?
Yeah. So you have new icon. There's still a little bit of work that is done on them. I think it will be I think it would be nice.
Okay.
Yeah, there's still some fine-tuning things to center a little bit. But overall, I think it's clean.
What was it again, Etienne? There was some things that didn't really have icons before.
Let me think. I mean, yeah, okay. There's been a lot of change, like the shape changes. Like if there is parameters inside, it's a square. If there's no parameter inside, so they are wrong, these icons. I can see because I can see a ramp that is a square. The
Okay,
border,
so I mean, if I say net
circle.
model, some random thing, okay?
I hope it's merged. It should be.
That is very slow. Are these in the CDN? Are these networks in the CDN? That's something.
What is the CDN?
Content delivery network. Who is handling Jezebel? Okay.
Yep.
Could you please check that?
Yes.
That's an issue for. I kind of think that is. Let me see. Well, actually, Ben H. Is project managing that, I believe, making sure that things. So you understand the issue is whether the CDN is something which is a global content delivery network.
I manage the CDN, Stephen. I know what that is.
No, you know what that is. I'm telling Etienne.
Oh, okay.
Right, but the issue is pushing all the things in the neural net repository to the CDN. Right?
Mm-hmm.
Because that download speed was ridiculously slow. Okay, so what am I supposed to see here?
So each time you see a net graph, and so in some you see icons, which is not the case until you click on, is there a net graph here? Don't find it. No, there's no net graph here. So maybe copy an example of net graph documentation. Or, yeah, I don't know. Yeah, if you copy this, you'll see that, I mean, this one, nothing much will change, just the shape. I think that some will get round. And there you go. So you see the ramp is round now because there's no parameter in it.
It bothers me to see pink like that. I think we should get another kind of pink.
Yeah, I mean, it's already another kind of pink than the error. We tried something else, blue, and many people didn't like it. We didn't find the right color, but I agree that I would love to find a better color.
Well,
we changed the loss function, is purple now.
Maybe what we need to do is just border these with red and not put them in full pink, so to speak. Border them red to show that they're not initialized. I also think that uninitialized icon there is a little bit ugly.
Yeah. The one initialized is great. I like the pastel.
This one here.
Yeah. This colors.
Yeah, that's fine.
And if you initialize a net graph, I don't know. Let's try to find some others. Like if you scroll down on net graph, let's see. There might be some.
Well, let's find
maybe take a big. Which one? Let me find net model.
But something which has an LSTM.
Net model. Maybe the CapsNet. CapsNet will have a lot of things.
Yeah, well, this just had a bug, an error. Oh my God, I don't believe this. Jezebel, do you see what it just did?
Yeah.
It's just incredible. It's a gremlin.
Do you have multiple Wolfram engines open right now?
I do not.
Okay.
I do not. And this is a single one, and it's been just unbelievable.
Okay. I will.
Sabotage.
I've had these gremlins in years past.
This particular gremlin that sets this particular thing?
It keeps resetting the setting.
Yep. I had to go into the option inspector to correct it.
No, we've already done that.
Multiple times.
Way deeper than that.
Yes. Yeah. No. The fact that it resets.
This gremlin has been installed.
The init file, and the init file got rewritten. So something's rewriting. Something's overwriting the init file with the preference.
Yeah, no, if it happens repeatedly, then obviously it's being
But by the
reset.
way, somebody should ask Filippo in Solutions, who gave me the thing that almost certainly did this, in more detail what he did.
Okay.
Right? In detail what he gave me.
Filippo. Okay. Will do.
Really annoying. Okay. Anyway, that's the thing that's happening here. This is giving some key value, whatever it was, thing.
Okay. So now you can see the one on the left. Yeah, you can click it. The one that are thick, which I think is a little bit too thick, the border, indicate that there's stuff inside. So it means it's not a leaf of the graph, so to speak. I mean, of this tree.
Oh, and I like the dotted lines indicating that that's what I've selected. That's nice.
Yeah. And so if you click the one, there should be something else to click. Net map operator. Yeah, there's a ramp. You can click the ramp. Net ramp. That's the.
Okay. So here, if I want to get from the net graph, from this thing, I want to get that image out. How do I get that image? How do I get the for publication image type thing?
It's information, and there might be probably a property. I don't remember exactly, but check the properties. Check second argument, you do properties, and I think
summary graphic.
Maybe yeah. I think it's that, yeah.
I think we should have a mechanism. Yeah, nice. Why did that happen?
Maybe there's a plot version. This is still a graph. A graphic, actually.
Well, that's a graphic because we can see from the orange border. It's not obviously bad, but it's slightly funky. But listen, I think we should expose this more obviously, because I think it's a really nice feature that you can get these icons and people won't know you can do that. So I'm just kind of wondering how we do that, whether we have a little thing at the bottom here that is, a copy graphic or something. Do you see what I'm saying?
Yeah.
That sounds like a really good idea to me, because then you can't avoid it. You'll get reminded every time.
Right, or even a mouse over on the graphic itself or something. And we need a graphical mechanism to say you can copy the graphic.
Yeah, and there's a lot of interactivity already in these things, but why not?
Right. Right, okay. By the way, Ali on our live stream is getting concerned. That means we won't be able to use NetTrain with GPUs in 12.2. Don't worry, we will solve the problem.
Yes,
that's the feature of having these live streams, is that there are aspects of the construction of the sausage which seem quite scary.
Oh yeah, this is nothing. We'll
yeah, we'll get solved. Okay. Custom layer. Now, didn't
compiled.
we?
Compiled. Yeah.
It's compiled layer.
Compiled, yeah. Compiled layer, yeah, it has been merged, but it's not. Oh no, it's not. This is
So how are we storing the compiled code?
Unfortunately, right now it's not stored in any efficient manner. So it will still take time.
Okay, so I am 99% certain you can use this framework of Christopher's to do it. Did you investigate that?
Not with Christ. I mean, not with Christopher. We talked with Tom, and there was no. I mean, a little bit of.
No.
Second-hand information. It's Matteo that has been dealing with them.
No. This is another one of these, got to be solved thing. Okay, so listen.
Yeah, I agree with that.
One of these issues with the function repository, right? We have some functions that, in fact, we had one that just should have got submitted in the last couple of days that uses compiled code, right? So I'm insisting that in the function repository, right, when we know what machine type you're on, so we know what, dynamic library or whatever you should be downloading, okay? So there is supposed to be some plumbing to make that work. Now, the case that you have here, where somebody has stored a compiled layer I mean, I think what we've agreed is that the compiler will throw things into the local object store as a cache. Yeah, I think that's what we agreed. I think Christopher and I looked at that, and I think the idea is once you've compiled something, it will crypto hash the thing you compiled, and throw a version into the local object store. And if you're compiling the same thing again, it will just use the same compiled code. Do you see what I'm saying?
Yeah. Okay.
So, I mean, I don't know who is project managing that process of getting, who is PMing the compiler project in general? Isabel, do you happen to know?
I think it was Andrea, but I'll check.
Okay, it may need, this particular issue may need some forcefulness. There seems to be some level of confusion about it, but the basic point is you should be storing in a byte array the actual compiled code, on a per platform basis, et cetera, et cetera, et cetera, et cetera, et cetera. Right? These layers will not be a lot of code, right? Or will they? Will they have lots of weights in them and things?
I think normally they're pretty simple.
Okay, fine.
Yeah,
Right. Then it should be
simple.
easy. All right, fine. Okay. Let's make sure this works, okay? It's not going to work to have the compiled layer be recompiled. The thing that I was compiling took 90 seconds to compile. Okay, it's back in the, in the old days before compilers were fast. Back in the 1970s, compilers were slow, and you had to do like 2 hours to compile things and so on.
Mm-hmm.
Okay, what's net function?
Right. Function layer, since we recently renamed it.
Okay, does it exist?
Yep.
I mean,
yeah. If you look for function layer, you should find it.
okay, so this is the very modest set of things that we can do that we can sort of compile directly, right?
Yeah.
So if I say, how would I first see if I say net? Oops, function layer isn't showing up as working. But
yeah, I think it has been merged. Right.
What is the message if it doesn't work?
I don't know.
Should be documented in possible issues, presumably.
Yeah.
Let's forget the please thank you thing. Let's just say use one or the other.
Yeah. I haven't reviewed all of this yet. It has been quite last minute.
Oh, we can have the please and thank you. I suppose it's just weird because we don't do that anywhere else. I wouldn't have expected Matteo to be the leader of politeness and messages.
It's Jerome. It's Jerome.
Oh, okay. Okay, what's it going to do though if there's a function that is not supported? I mean, it just says sorry, that function isn't supported.
I think so. Yes.
I don't see any alternative to that. I mean, but maybe we should point people to compiled layer in some cases.
Mm-hmm.
It's going to be hard to understand what function layer does versus what compiled layer does.
Yeah. I mean, we kind of explained that internally it converts to a net graph. So I think that can make things clearer. And actually, you can see here, you see at the top of function layer, you have the function, and then you have the net. And you can click one or the others to see either the function or the net.
Oh, I see.
Yeah. So we always this duality, and it's pretty clear that it's a net as well.
Right. I mean, now the representation of this as a net reminds one of code graphs and reminds one of the automatic differentiation discussion that we had. The fact that it's possible to represent this as a net. I mean, I kind of realized from that discussion, the key idea, just to repeat that for a second, the key idea is it's kind of like sort of variation at every corner, so to speak. You've got a you've got an evaluation of a function. It goes through many steps. There are many, there's 100 variables, and you've got a particular value of those 100 variables. Now you want to do sensitivity analysis, basically, with respect to those 100 variables. And insofar as it's a call graph or a code graph, it is basically just the chain rule, and basically the variation of the whole thing is the variation of every, is the result of varying every, to first order, I mean, this is me learning calculus, okay? To first order, the variation of the whole thing is just the sum of the variations at every node of the code graph, right?
Mm-hmm.
So in a sense, what that's doing is it's making real the notion that the derivative is the first order, first. I mean, that's a very straightforward thing for us to imagine doing. That is, we have a function represented somehow. It's a piece of functional programming that has a fixed number of, you can't vary the depth of the you have to have something which has a definite number of unrollings. You can't say there's a parameter that has, it goes from 5 to 6. It's incremental. Everything is every parameter that's going to be varied is a real number, and there better not be any branch cuts or any other weird stuff going on, right? And then what we're saying is we're just going to take that and take the symbolic representation of that and vary it at every turn, so to speak. So in other words, what we're saying is for every function, f of x, in that thing, we also have a what we might call, first order variation of f, if this is making sense. Roger, are you following this?
I think you were in a very roundabout way trying to explain the different automatic differentiation.
Yes, that's what I'm doing. I'm trying to explain it in a way that we can immediately implement, because what I'm saying is if you have f of g of h of whatever it is, right? You have some complicated function. What I'm saying is, so long as we say that if we say that first order variation, let's say, of f of x, right, does something definite, that's what we need for automatic differentiation. So Rob was talking about all these adjunct derivatives and so on. Mm-hmm. I'm just saying that what we need is simply for every argument. I mean, what we need is something which is essentially the derivative, except it's a numerical version of that. It's essentially exactly what we have right now for derivative. We're just writing this thing out. We're going through this whole thing here, applying the chain rule, and doing this. And I don't think we need something different. I think we need a numerical version of our current derivative idea. I'm just unconfusing myself. I think I'm now unconfused here. And I think that the whole thing about directional adjoint derivatives and so on is a different herring. Not entirely red, but a herring of a different color.
Well, it's just projection of the Jacobian on some direction, and sometimes useful.
I realize that, but that's the ultimate thing you're doing is you're taking every function and every variable in every function, and you're just wiggling it a bit, and you're seeing what happens.
Yes. Also known as derivative.
Yes, also known as derivative. That's right. Which is exactly what we call it, is derivative. Right?
Yes. No, I mean, the thing that we looked at, it's not for this version, but this adjoint derivative and directional derivative, they are needed partly because you want to be able to express that from outside, from these parameters.
I agree. Yes, I agree. I agree. You absolutely need that. But the thing that rodentifies, the thing that burrows into the expression, I think is just derivative.
It
or a
is.
numerical version.
No, it is. It is. An AD, automatic differentiation, is an organized way of doing that.
Yeah, I understand, but it's, yeah, right. I get it. I've now understood exactly what has to be done there. Right. I mean, I'm part of, yeah. I mean, part of my effort to understand calculus is, you know, because of the generalization of calculus that we need for these fractional dimensional spaces. So that's my other use case for this, for understanding this.
I see. Yeah.
All right. Cluster dissimilarity loss layer.
This is gone. This is not.
Not going to make it.
This is no. It's something that it's more the image processing team that is working on it, but Jérôme is also working with them on that. It's something to train feature extractors, neural network feature extractors, and yeah, there's this new type of loss, which is a little bit weird. So there will be some design there. Yeah, but
Okay.
not for 12.2. Placeholder, yes, that's making it. So very simple layer.
What the heck is it?
It's something. It's. I think we talked about it already. It's when you import a network, and there's, let's say, a layer that cannot be converted. It will replace it in terms of failing. It will replace it with a placeholder layer that then you can go by hand and maybe replace with a good.
Okay, but what you want to do, if you do the import, you absolutely need in that placeholder layer, in the association, you need whatever the text was of the layer you couldn't import.
Mm-hmm.
Right?
Yeah, that's yeah.
So, what are you going to call that?
For the ONNX importer to, yeah.
What are you going to call that? I mean, so in other words, I mean, what you've got to explain is that this placeholder layer.
I don't remember. I think it might do that already. I'm not sure.
Well, it doesn't say it does that.
Yeah.
Suppose the following options. I mean, it doesn't say it does that. I think, let's see. What should it be called? I mean, we have that issue in the front end. We put into tagging rules things that come from importing other formats where we can't, you know, where it's a meaningless piece of information. Now, when we get something in, is it going to be a piece of text or is it going to be more structured? I mean, it might also be contextualized, right, when it comes in here. Do you understand what I'm saying?
No.
What I mean by that is the ONNX import of some layer, right? What is it which came in? Is it, you know, I have no idea what native ONNX looks like. Do you see what I'm saying?
When we import, it's going to be one of our layer. There's no representation of ONNX. Okay.
But what I'm saying is exactly this. You said it's a layer we can't import, right?
Yes, exactly.
Okay, so what I'm saying is that corresponded to 10 lines of ONNX code, whatever that looks like.
Oh, I see, yeah.
Okay, and what I'm saying is put those 10 lines of ONNX code into the association in placeholder layer. So when you're looking at the thing, it's like, oh, okay, now I see what that is. Let me go and untangle it.
Yeah.
But isn't that just pick a standard key where it goes?
Yes, but what I'm asking is, I don't know what ONNX looks like, and I do not know whether it is textual in that sense, or whether the thing, whether you need a whole, like let's imagine that ONNX was like EXIF data from an image, right?
Yeah.
You could have the EXIF string, but it'd be more useful to break it out into some pieces. See what I'm saying?
Yeah.
So that's all I'm asking is, what's the natural way of importing?
I think we need to then look into that. But like EXIF, we can't make everything. We did for the you know,
No, I
for
know.
things that are
pulled
numbers,
out
we
some
we
obvious-
make numbers. And
yeah, we did obvious things with EXIF, but people EXIF, some random manufacturer of moon cameras or something can add
Right.
all kinds of other junk to the EXIF data.
and they have, yeah.
Yeah, right. Which we can't import. It's fine. It's just a key value thing for us.
Right.
But in this case, what I want to know is something like what do we want to call this? I think we should call it like imported string. Okay, in the association. Does that make sense, Etienne?
Yeah.
Okay, but as I say, if there is more structure, let's preserve that structure.
Yes.
I mean, if the importer knows that, for example, this is in this environment with these variables, blah 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 blah, let's preserve whatever structure the importer had, and put that into the internals of the importer into this layer. But
it's probably been passed already a little bit at the point where it cannot convert.
Well, right, that's my point. So I'm saying preserve that parsed information. But I would say that the bottom line, if nothing else can be done, would be call it imported string.
Or imported code, or
Imported code is fine. Who knows what it is? Yes, fine.
Yeah.
Right. Okay. And this should explain what does this layer do if you just run a neural net. This layer is a no-op. Is that correct?
Yes. I don't think it will return anything.
Well, that's two different statements. A no-op is not the same as saying it returns nothing. What I was assuming it would do is pass through the data. That its output is equal to its input, or does it have separately defined input and output ports? What does it do? Does it generate an error, or what does it do?
I think so. Yes, I think it will an error. I don't know actually.
Okay, fine.
I mean, the point is not to use it. The point is to replace it.
I'm aware of that. I'm just asking what it actually does. If by some so look, to my mind, right, there are two things. So we can have a network that's uninitialized and it says, oh, I'm uninitialized, right? And it can't do anything useful. I don't, what does it do when you apply an uninitialized network to data? What will come out? Does it allow you
message?
To do it?
No,
okay,
no,
fine.
No.
I know. Okay, fine. So this is the same thing. So if there is a network that contains placeholder layers, it needs to say, I mean, are we sure it should be called placeholder layer rather than undefined layer?
Rather than what? Sorry?
Undefined layer.
Undefined layer. We didn't come up with that name. Undefined layer.
I think that's a better name for it. I mean, it's really an error condition, basically.
Mm-hmm. Yeah, I mean, undefined seems fine to me.
Okay, then what we should do is state that there is an undefined layer. If you have a network and you're looking at it and you see the visual thing, it should say with a little red thing, 2 undefined layers or something.
Yeah, I guess the placeholder name might be good when you are actually using to construct network. Sometimes you're like, okay, I know that this part of the network will take this amount of input, this amount of output, so I'm just put a placeholder, then I can construct things around it, and then I will replace it. I mean, we can imagine doing things like that. I don't know how much is going to be used. And in that sense, it's really a placeholder, but undefined.
I don't know. I don't know. Ask the rest of the team. I tend to think that, but it is important that we tag it to say, even at the top level, there are 3 undefined layers in this network, right? So you don't try running it and things.
Mm-hmm.
Does that make sense?
Yeah.
Okay. Oh boy. And this is called a random array layer rather than a random variate layer. Why?
Because it returned an array, and we had all this XX array layer.
All right. Okay. Fine.
But honestly, I mean, I think
I think random array.
actually
is
random
better.
variant. Yeah, maybe random variant is good, huh?
I don't know. I think random array layer is okay. If it has the feature. By the way, if you say random array layer open close, surely it should just generate a uniform distribution from 0 to 1.
If you don't specify any distribution, it's uniform by default. Yeah, okay. Yeah.
Seems sensible.
Yeah, I agree.
I think random array is better than random variant. I think random variant is
Okay.
too weird. Okay. Did this get horrifying, this threading layer thing?
Well, the one addition is this broadcast thing.
And how is that being
that
done?
we really need, and it's done with a number that specifies.
Yeah. Well, look,
you know,
as far as I'm concerned, these functions are still basically the machine code of machine learning. Yeah, it's fine.
Yeah, I mean, hopefully people will, function layer will be very successful, and its successor will.
Right. Okay, Onyx export. Let's talk about that. Do we have workflows written to describe how you do export from Onyx to Core ML and all this kind of stuff?
It's being done right now. So Geoffrey is working on training, actually getting some data, training, exporting to Onyx, converting to Core ML, and make it run on his iPhone. And he actually managed to do it.
Good.
So he has a network that is running on his iPhone, and he's now writing a blog about it.
Cool.
And,
okay. So one place where that's important is the front end team is working on this, some of this OCR stuff. You're aware of this, right?
Yes, Etienne responded to the thread too when I said
fine.
Onyx is the method.
Okay, all right. But did they seem to accept that, or were they still saying they're trying to use random C code from somewhere?
I'm not sure they plan to use a network. I think it was just one of the possibilities. So
right, but
this was relevant only if they.
I understand, but the absolute thing that they cannot do is start writing custom C code to run on a random phone to do this particular thing. We'd be better off using.
I think it would be good to follow up. Who was doing the? Was it Geoffrey? Did you say?
No. Well, yeah, Geoffrey should talk to Nick Zitman, I guess, who's doing the.
Yeah, that would be really good case to see.
Fine. But my point of view is this, and it kind of follows your analysis of neural nets, Roger. This is basically, we now have a hammer, even though there might be classical image processing algorithms that could be used for this purpose, because we now have a hammer, let's use it, so to speak.
Yeah.
Right.
But in particular, and I also think that this is super useful, this for many people, including our own teams, to get the artifacts out and be able to use them.
Right, but that means so Geoffrey is going to write the workflow documentation. Is that correct, Etienne?
Yes, exactly. I want blog post and then whatever tutorial.
No, workflow documentation. I said something specific, right?
Okay.
Our workflows. You know what I'm talking about, right?
I haven't. No.
Okay.
Oh.
We can talk about that, Etienne.
Yeah. I think I don't think we
look. See this? See all these things down here? Deploying to web and mobile. Wouldn't it be nice to have something here that says, set up a repeated use form page, right? Well, that's one thing, but this is deploy to a phone, deploy a neural net to a phone.
Yeah, I think that makes complete sense that it does it. I mean, I had in mind to do some sort of tutorials and everything we can do in documentation about it.
Right, but this is the place for it. This is the type of
actually, Etienne. So under O for the DocuTools palette, there is workflow tagging, and there are. If you ask on TNUDocs, they'll point you to the videos that explain it.
Okay.
Right. The whole point about workflow documentation is it's for documenting your path through the jungle.
Yeah.
Okay, because in other words, these things are not, this here, you see this? This has things like, copy and address of a hyperlink and all that. And it's showing stuff which is, this is the jungle, right?
That is perfect for the ONNX to core ML thing.
Yes. So we wrote a ton of these, for instance, for the Unity link and others that also crosses platforms, if you like.
Right. This is the only way to do it. I mean, this is a different style of documentation from our usual documentation, and it's what we need. So what are the other targets for the Onyx export?
Maybe something for Android, I don't know.
I think we should look into, we should follow up with the Onyx organization, identify as their partner organizations and use cases, which means that all of those should be open. Yeah,
that's right. That's a good thing to do.
Because in effect, there are tons of accelerators, particularly for inference, that are being, there's about 30 chip startup companies, for instance. They better accept Onyx, or a big fraction of them do.
Right. So those are companies we should probably contact. Fine. Yeah. That's part of the developer relations story. Okay. Let's see. By the way, there's some comments on our live stream here. Ali is saying CUDA function load seems to be not working in 12.1.1, even though machine learning on GPUs works in Windows 10. Although the CUDA function load works in 12.0, is there some package installation problem for 12.1.1? I don't think anybody here knows, but let's go.
No, I think we need someone that's like SQA would know probably if there was such a known problem.
Okay, Jezebel, can you clip that out and ask them?
Yes, of course.
IC is asking, is there a way to get a list of all tutorials in the documentation? That's a good suggestion. There isn't.
Right. We used to have some kind of table of contents, but
right. Well, the reason we don't have it is because it's rather inconsistent. But I agree that there should be a place where there is simply a listing.
As a matter of fact, we're starting to invest in tutorials again and write new ones in a bigger way.
Yes. Well, I mean, the problem is for many years, every tutorial was a deconstructed version of the of my original Mathematica book.
Yeah, exactly.
And
we also had the impression, the feedback that I felt we got from users was that nobody wanted to read it, and they wanted to see sort of the immediate examples was the big push.
Right.
But now we got to tie the story together, which also some after a while pointed out to us. And so that's.
Well, I think the point is that these subsystems that we have, what happened is originally the whole system was small enough that it could be described in a 600-page book. Then it became much bigger. Then individual subsystems get to the point where they are describable in 200-page books. And that's what we need.
Yep.
And yes, that's a good suggestion. And can Jezebel, can you add that to the
yes.
New docs documentation review meeting?
Yep.
That's a Brady production. Machine learning on GPUs. Oh boy. Version 11.3 does not work with the NVIDIA Turing architecture GPU since it was compiled with CUDA Toolkit 9. Does that mean we need to run 11.3 on machines with the previous generation cards for the indefinite future? Nobody here knows the answer to
I'm
that.
also passing that to QA.
Okay. Okay, a question from Nick here. Any probabilistic layers for distributions and things like KL divergence or Cartesian low, whatever that was. Is that the ICA thing? Okay. Anybody know what that means?
Well, it was sort of similarities for distributions, right?
Yes.
And but I'm not sure what it means about probabilistic.
Oh boy, we have 4 separate people on our live stream saying, emphasizing how much they like tutorials. Good.
Okay, good. Well, there's more coming. There's quite a few under development.
And Push on our live stream is saying video tutorials, please. Well, no, what do you mean by video tutorials? Now let's understand what that means. Do you mean tutorials that are videos, or do you mean tutorials about our video functionality? We need to know the answer to that.
Well, there is a tutorial, a small tutorial about video, about the video functionality.
Okay.
And we have started to do, I think that with this, something requires more discussion internally, but if you know, on the live stream, if people have opinions of how to do maybe a short 1-minute intro to functions, video introductions to functions as an alternative for ref pages, for instance.
Yeah, do people want that? We would love to know that, because we could easily do it. We could have a developer. We could have one of these things that's like the, you know, the director of a movie saying hello at the beginning of the movie type thing. We can have the developers of functions kind of give their 1-minute summary of the function. Or is that too scary? We can include functions that are very old, where the developers, you know, developed it 30 years ago and things. Anyway, a question here from Ethan. Will GPT-2 and BERT variants be trainable in 12.2? I thought we did have trainability for some of those things. Etienne?
Did you say 10.2?
12.2.
Okay.
Did I say, I maybe said 10.2, but he said 12.2.
Okay.
I didn't know that we could not train them, because I mean, we have the models, so
We
what
should be
is-
able to train them.
Yeah, I don't see why.
Okay.
But
Ethan is
GPT-2 is pretty big, right? I mean, it's not like GPT-3, but it's
There's
big.
yeah, there's few versions. Yeah, so there's some versions that are smaller than others.
Okay.
right. Johnny here on the live stream is saying, will GPT-3 work with Maya and Wolfram language? But the
Actually,
GPT-3 is not as impressive as one might think. Go
actually,
ahead.
I realize, yes, it's a tokenizer that is not trainable. It's this BP tokenizer, and for the next version, you'll be able to train your BP tokenizer. So I guess
in 12.2.
answer. No, unfortunately not.
Okay.
Yeah, we didn't manage to put that in, but for the next one, it's definitely on the list, and it's going to get done.
I'm unfortunately going to have to run. I'm already in deep trouble.
Well, okay. So we need to. Okay. All right.
But
fine.
you guys can continue if you want.
I can continue for a little while. Yes.
Okay.
Okay. See you, Roger.
Right.
Okay. Pusher is saying means tutorials that are videos, and Brian is suggesting, why don't the documentation pages link to videos that have been made at our various conferences, which is a very sensible idea. I have no idea why we are not doing that. Jezebel, that's another one for you.
Sure.
Yeah, that's a good idea.
I mean, you know, the effort to edit those or even to re-record some of those.
And if you remember those live streams that were done for 12 and some for 12.1.
Yes, absolutely. Those have
those were also meant to be linked up from the documentation. I will follow up on who's working on that process.
I would have thought it was the video team, because I think that probably requires quite a bit of cutting up of the videos. Okay, let's take a look at array reduce. And also, all right, I want to tag it as experimental.
Yeah, I think that's good.
You don't have any C also here. It presumably wants to look at apply.
Yeah.
Flatten. What else does it look at?
And look, interestingly, that's how I should have printed it to you in the beginning. Integrate. It's a little bit remote, but it's kind of the same design. You tell the variable that you want to integrate over. And array reduce is the same thing. Like actually, array reduce of total is kind of the discrete version.
I'm sorry.
Integrate.
I'm going to put sum. I'm not going to put integrate. It's too weird to say integrate.
Sum. Can you sum over? Yeah, I guess.
Yes, you can. Right? Absolutely can. Yes.
Yeah, yeah. So I guess, yeah.
All right. Now, what about other?
I mean, there's yeah, transpose.
Is transpose relevant?
And
Yeah, transpose is
kind
relevant because
of, yeah.
it allows you to
Yeah.
pull things up to the top.
Yeah, yeah. I mean, flatten does as well. Flatten is more generic, actually. I mean, and then there's like, I don't know, just even map. I should probably put.
I think apply is more relevant, isn't it? Because apply actually does something to a layer.
I don't know.
Well, okay, we should
but
probably.
it doesn't go inside the head or reduce. F is given a list of stuff, like the head is not going away.
Well, fair enough. Is map at relevant? Not really.
No.
All right, let me consult my elephant here to find out where we have put array flatten. Okay, rearranging and restructuring lists.
Oh yeah, array reshape. Like, do we have things like that?
We do have array reshape, but we don't have it
Then-
listed here.
Then that should probably link it as well.
Where should we link that? At the end?
In the seal at the end, yeah. It's not that relevant, but it's kind of, changing dimensions.
Right. Okay, so then here, wow, what the heck is that? Pivot. Look at that. What do you know?
Level N, because the first level, it was my transpose with an arrow.
Well, look at this. When was this from?
And what is the several least and second argument? So that the family of subpart becomes the first level. That's
array reduce, isn't it?
It's one part, and it's actually kind of the inverse. Like, it's put things at the last level.
Okay, you better look at this. Take a look at this.
But this should be, yeah. This can be done. I think this can be included to transpose.
Okay. Well, so where should we put
Okay, array reduce.
should it go under transpose here? Should it go?
No, where do we put the map and things like that? Okay, this is.
Well, this is rearranging and restructuring lists.
Yeah. I mean, it's use a function, so I don't know. Still, okay. Maybe the first one with the flatten and partition catenate. Oh, maybe this is too generic. This, I don't know.
Well, okay, so I'm going to put it in here.
No, doesn't shock me.
Reduce.
Say dimension or
Dimensions of an array.
By applying a function.
Reduce the dimension. Okay. All right, now on this page, we also see some other things here. So array reshape definitely needs to talk about array reduce.
Yeah.
Probably before fold.
Reflatten, speak about a reduce. Maybe before, exactly, yeah. Put it there too.
It is amazing how easy it is to agree on where these on what the orderings should be. I thought it would be very difficult. Okay, flatten at. I don't think so. Okay, transpose needs to somewhere point to array reduce.
Yeah.
Where?
Toward the end. Honestly, I would put the end there.
Yeah. Okay. I wonder why we don't have array reshape in here. I think we should. Okay. Where else should this go? Okay, let's go and find other pages. Okay, I put it in those ones. Did I put it in array flatten?
I don't think so.
I think it goes there. I think. No, maybe not. Maybe it goes at the end.
I wonder what substitution system. Anyway.
Why it's there?
Yeah, I don't know the connection. But there must
The
be
reason
one.
is if you do two-dimensional substitution systems, it's just what it's doing is it's array flattening at every stage.
Okay.
I think it goes at most at the very end.
Yeah. I have to integrate for sure.
After table, I would think. Well.
Yeah. Summon table. Actually, I would have put table further up. Right? Summing is kind of the.
I like it at the end because you notice it there. It's kind of a different type of operation. Okay. Let's go back to the elephant. Reduce definitely goes in tensors. Does it go in structural matrices and convolution kernels? No, it does not. Handling arrays of data, I think it does go in that. applying functions to lists most definitely goes in that.
Yep.
Okay, and I'm going to put it in here. Okay, applying functions to lists. So now multi-element mapping. I think it needs its own section, doesn't it?
What is
Array reduction. And then we say reduce an array by applying a function along a certain axis on a certain dimension, at a certain dimension, at a certain level.
I avoid speaking. I mean, that's something we should decide. I avoid talking about level because level kind of involve, the expression and everything that is below.
Okay.
So I
reduce
speak
an
about
array
dimension.
by applying a function at a certain dimension. Well,
I use that in the old documentation, but I don't know.
What do you say exactly in the documentation?
I say dimension. I mean, you can look. It's just behind. So then I say, yeah.
Reduce the dimension of an array. Reduce the dimension of. No.
Sometimes I say applying f to the vector along the dimension.
Okay, by applying a function
dimension.
along a certain dimension.
Which, when you visualize the array, geometrically makes complete sense.
I think we can say a certain dimension. It's the most common case.
Yeah.
Yeah, I like it. Okay. Now here, yeah, we put it in there. Okay, tensors. Okay, so it goes in this section here. Right?
Yeah.
I think it just goes at the end of that section.
I mean, yeah, definitely. With the in
Okay.
out.
Okay. What do we say? Reduce by by applying a function at a certain index. What is the right term? It's at
Well, transpose say indices. So.
Okay, well, but by applying a function to a certain indices, that's specified indices. What do you call the slots in a tensor? Tmu new. What do you call the new in that?
You're asking the wrong physicist.
Well, well, we have to ask Jose to certain indices or something. Yasbel, could you just see, this is a
Yeah.
like a 2 minute, 1 minute Jose question.
Yeah.
Meanwhile, there's a bunch of comments on for people on a live stream. Okay, Ethan is saying, please add a concept of a detect function. There's no way to train detectors. Detect for images. Okay, I mean, detection is a type of machine learning problem not doable by classify and predict.
Mm-hmm.
So I think a superfunction called detect.
Yeah, we thought a little bit about things like that, yeah.
Well, what would be the idea? The idea, I mean, we have anomaly detect, right?
Yeah, but that's different. So it means function that finds subset in examples, such as image cases, that finds, detect some object that we could generalize to, also to sound, to extract some part in the sound, or extract some part in time series, or extract.
So wait. So you're saying what this would be is, oh, I see. So this is, yeah, we have wanted this. This is exactly the operation that I've talked about forever, with like find the dogs in the image type thing. It's image cases, basically.
Yeah. And
so the general case is detect cases, basically.
Yeah.
It's a good suggestion. I mean, it has been on our list for some time, but I like the name detect cases.
Mm-hmm. And yeah, this person would want something that we can train such detector.
Right.
Yeah, there's all a class of these things, and including anomalies for time series, where a bit like the peak detect type thing, but more general for anomalies. Design-wise, they're always a bit more tricky. I think there's several ways to train them.
I know, but hey, listen, look, let's just put that. That is, that has been from 2-3 years ago. That was one of the super function goals that we had. We wanted to do trainable image cases. We haven't managed to do that. But this is definitely an important future thing. Can you make sure that's added to the sort of super functions list?
Yeah.
Okay. And let's see, we do have, did we manage to get Jose here by any chance? No, it doesn't look like
No,
it.
not yet. I'm still trying.
So meanwhile, comments about Ali's questions about various kinds of hardware, GPU stuff. Says there, somebody, I don't even know who's responding to this, says there are two different issues, CUDA link and neural networks. They have separate implementations and separate code packlets. Okay, CUDA function load can fail for various reasons, e.g. compiler installations, but that should have no effect on machine learning. NetTrain will have GPU support in 12.2. Oh, for goodness sake. Although there's an uncertainty in Mac OS due to the Apple NVIDIA problem over CUDA, resulting in no Mac OS drivers for CUDA for several years. Okay, so the comment about Turing cards are too recent and not supported in 11.3, so upgrade. Good thing to do.
And it turns out that this person is at the most current version anyways. So we're suggesting that he contacts support.
Okay, all right, so there's some other problem. Okay,
yeah.
Jose is here. Jose, we have a really simple question for you. The array reduced function, how would you describe that for a tensor?
How would I describe that for a tensor?
So it's saying reduce by applying a function to, but you don't say to certain indices. What do you call the slots in a tensor?
Well, in the Wolfram language, I usually refer to arrays and levels. If I'm talking about tensors, like in a geometric way, like I would do in general relativity, I usually use slots or indices. To me, the tensor has slots, and what I put in the slots are the indices.
No, I agree. So this is a page about tensors. There's a guide page about tensors, and we're adding array reduce along with generalized trace and other such things.
I see.
Reduce along any dimension with any function. Is that a reasonable thing to say? Along with dot product, generalized inner product, generalized outer product, and so on?
Yes.
Unfortunately, dimension isn't the right word, really.
I think level it would be more appropriate here. Level.
But that's using our representation of tensors, and Etienne has wanted to avoid level because he thinks it involves subtrees. This is really the index, right? I mean, it's R alpha, beta, gamma, delta, and this is saying take the index gamma and sum over all, it's like a one-legged Einstein summation convention. Isn't that correct?
Yes, but if I remember correctly, array reduce can handle several of these indices at the same time, right?
It can.
It's a bit like flatten in that sense.
Yes. But does it always apply the same function to all the different index levels? Etienne?
Say again.
Combining all dimensions nij to make a dimension ni. So it doesn't have the possibility of having multiple different functions to apply to different levels.
No, it's one function, and it's yeah.
Okay, so I'm going to come back to my question to Jose. I mean, you say if we want to describe this purely in terms of tensors, geometric tensor type stuff, right? And you are describing R alpha, beta, gamma. What is gamma? What kind of a thing is gamma?
In the tensor language, I would use the word index.
Okay, but can you fit it into this sentence that I'm writing? Reduce along any index with any function.
Well, you could use tensor index to be specific.
So what could I say? Reduce a tensor index. Reduce along any tensor index? Across tensor indices? No, it's not. We don't want to say across. Actually, you know what? We could just say reduce any tensor index with any function.
Yes.
Does that make sense?
Yeah, or you could say reduce any tensor indices, because it can be one or more with a function.
All right. Okay. That's good.
Maybe with a function, because any function is a bit weird because it has to be a function that reduces, right? Like just be a total mean or something. I mean, it could be something else, but it doesn't really. I mean, the main use case is this sort of functions.
Let's just say that. It's pretty obvious what that means.
Mm-hmm.
All right, I agree with you that A is better than any.
So what do we use in flatten?
We don't even mention flatten on the page for tensors because it's a really weird operation.
Right. So, but flatten uses the level notation.
It does, but it's doing something very different. I mean, no, it isn't doing something different. It's just that for this page, this is specifically a page about tensors, right?
Mm-hmm.
So that's why I'm using tensor language here. And in the world of flattening tensors, right, which is a completely operation you absolutely do not do in general relativity, right? To flatten operation is insane in general relativity. If I'm
yes, but I'm not sure that the reduction is much better in that sense. So this reduction to me feels in the category of.
I mean, it doesn't combine apples and carrots.
No, it's Jose. It's one-legged Einstein summation convention, right? It's just, you know, the Einstein summation convention usually is two indices which are essentially dotting together. This is saying just take one index and reduce along it. It's not such a crazy operation, and I think in isn't it equivalent if you were to take this for two indices? I think it will be equivalent to the summation convention. If I'm not mistaken. No, actually it would be, no, it isn't quite equivalent, because in the summation convention, you're taking, in this thing, you're taking the whole bag of things.
Right. So if you use mean on, say, a level 2 slice, that's not a tensorial operation.
Yeah.
No,
okay,
thinking of
fair
the last
enough.
line.
Which, sorry, what?
The last definition in the box. So this ability of manipulating multiple indices at the same time is
Yeah,
something
that's a funky thing.
Yeah, that I only associate with flatten.
Okay, just for your entertainment, for your physics entertainment, okay?
Mm-hmm.
One of the new things in our whole, you know, way of you know, deriving quantum mechanics is the absolutely bonkers thing that what seems to happen is that these quantum phases basically come about from space-filling curves applied to branchial space. That is, you have a two-dimensional thing in branchials, the two-dimensional thing which would naturally be two-dimensional, and literally the quantum phase comes about by actually having a weird space-filling curve that walks around the thing. Isn't that totally bizarre? And it looks like this. I mean, anyway, still some things to be understood about it, but it's very weird. I've never seen anything like that. It's a place where you actually have a flatten that's coming out from this weird higher category stuff, is essentially implementing a flatten.
I see.
It's really weird.
Mm-hmm.
Okay, that was what we wanted, I think, for this. Anything else for Jose here? No? Okay, thanks, Jose.
Okay, thank you. Bye.
Bye. Okay. Okay, awesome to be able to export a standalone DLL or even C code for a trained classifier. That's exactly what we should have from Onyx Export. SL8 is saying video tutorials will be, function video tutorials will be okay. First and foremost, oh boy, this is talking about the interdependence of products in our product line. That's something that's in Jezebel's area. Well, it's an interesting comment from SL8, which you can look at, Jezebel.
Yep.
Right. Okay. Last items here from Etienne. Oops. Do I need to save array reduce? I don't think I touched array reduce. I don't want to save it. Yeah. Oh, did I? Wait. Yes, I did. I put in its C also. So I did.
Oh, yeah, of course. Of course. What do you think of the graphic?
I don't think it's bad. Yeah,
I kind of hack it up today, and
right. You like these annotations of arrays, and I don't think they're bad.
Yeah. Otherwise, I think we saw.
Okay, let's take a look at the the search thing. Okay. So what's happening here with the search system?
Oh, but this is just the ongoing project of improving the search, which go incrementally. There haven't been any revolution.
Wait a minute.
So
Did the entity thing get done? Did the Wolfram Alpha search thing get done?
Oh, this I'm not sure. This
Okay, because that has to do with
I
putting.
think so. I think so. But
Okay, so can I see it someplace?
yeah,
Let's say Chicago here. Oh, for goodness sake. No, I'm not seeing it here.
yeah.
Right. So that's what I want to see is I want to see the entity search come up at the top, right? Which we can do from the Wolfram Alpha query recognizer.
I thought it was okay.
Well, maybe it's just not available on the yet in product here, because that's a complicated thing. It's got to have both. Okay. Okay. Right.
Wait, just a random thing. I don't know if you want to redocument it, but I did something to convert, a fitted model, like the classic statistical model, to predictor function.
Yes.
So if you do predict of a fitted model, it will convert it to a predictor function, which has been asked by people. But actually, the reason they asked was to use in classifier measurements. Predictor measurements. But since now you can use predictor measurements without a predictor, that useful. But I think it might be good that we start connecting the statistics and the machine learning.
Absolutely. Look, what we really need to do is to do
bit.
a pass, which I think you and your team should do on the statistics functionality to modernize it, given what we now know about machine learning, both in terms of the input parsing and some of the presentation and so on. I don't think it's very difficult. I think it's like now that you can fly a starship, you can fly a helicopter type thing. That stuff is 1930s type technology.
Yeah. I mean, there's some differences.
But I think a lot of those things, like all the indicators and things like that, we now have more sophisticated versions of stuff like that, and we have more sophisticated frameworks for displaying, complicated diagnostic information from doing, analysis. All right. So I don't really. This is not really a review of the search stuff since we don't have the relevant people here. So I mean, that's a separate thing to review that and understand what's happening with it. And the one thing that I thought we were going to see didn't work. So not encouraging. All right. Anything else?
I mean, I can tell you in terms of results, I mean, on our benchmark, things are quite improving. There's still some road to travel, but
okay.
I think it's not excessively better, the search.
Okay. Well, fine. But I mean, I think there's a certain amount of stuff to do with being able to extract the information from the original documents, and then there's the question of how the ranking works. Are we yet using our machine learning stuff in the ranking pipeline?
Well, not directly. We are using a data set to improve the parameters that are in Lucene. My strategy was always to push Lucene kind of to the end, and I think there's still a little bit of margin we can get. And when we're stuck, try to get the bigger guns by just changing the model and having a more complex model. And potentially a better data set as well. We start seeing the limit of our data set. But of course, creating data set by hand is a kind of, but we're getting better. Like we create small data set by hand, like 100 queries here, 100 queries there.
Who is ranking them?
It's Nicolas. It's Nicolas, and usually it's okay.
But I mean, the problem is what happened previously. No, we had a kind of ranking panel of a bunch of people, and what ended up happening is, I mean, this is something that maybe maybe even at the conference this coming week, we could ask some people to rank some stuff. Why don't we find out whether that's possible? If we've got some ranking tests, because the problem was when we asked for rankings, even from internal people disagreed on what the rankings should be dramatically.
Yeah, I mean, I don't know what set up the problem, but the 10th position, we don't care. Like, if you simplify it, like just give your top 3. I'm sure
I agree.
that there will
I
be
agree,
some big overlap between people.
Well, yes and no. What we found is that people with different levels of sophistication were picking out different things to be at the top.
Yeah. Well, yeah, it can be good. Even they are different, it's still data set that will be much better than what we have.
Well, we have such a data set. We made it like 3 years ago or something. We had a bunch of people do that for many queries. So if you don't have that data set, you should have it.
Yeah. Also, Arnoud was leading this effort to obtain, I guess, from the cloud. Oh no, from the product, like that users could kind of opt in to have data about what they click on the documentation search, and then we can infer that if they click position 6, then it should be bumped up.
Yep.
And that would be good.
Yep. All right. Oh yeah, he's Ali is commenting, wants pointers to scientific literature for which algorithms are being used in for particular functions. Oh yeah, that's a complicated story. I mean, it's a good topic to discuss. It's just complicated because it's often combinations of things and it's our own version of them and this and that and the other. Yeah, we should have that, not for today, but that's a discussion. And again, I think the fraction of people who care is much smaller than you think. Most people just see, I mean, one cares when an algorithm is rather heuristic. To quote how we compute a Bessel function, it's like, well, it'd be nice to give credit to the, person who figured out the algorithm, which is probably somebody internal to our company in this case. But it's not really necessary because unless we messed it up, it's just the value of a Bessel function. But in other cases where it's much more arbitrary, like a friend of mine for a while was the most cited scientific author because he was one of the authors of the BLAST standard for sequence alignment, which essentially has a heuristic in it. And so it's not like if it was like a precise sequence alignment, which is what it was supposed to be, but it had to have a heuristic. And so that meant it had to be quoted everywhere because that was the definition of what, which sequence alignment you were using. Anyway, can we, in fact, that is a good topic for probably the documentation meeting. Maybe Yazabel could get that added to that.
Yes, I got it. Yeah.
Okay. All right. Okay. Thanks, everybody. Thanks to folks who've been following this on the live stream. I think we have several more live streams tomorrow. I can see that as we approach this release, the intensity gets higher. And of course, there's the technology conference next week, which particularly since everything is remote, I hope lots of people will be able to come to. All right. See you all later. See you, Etienne. It's probably late. Oh, now that you've moved to that side of the world, it's now late for you.
Yeah.
Oh, well. Okay.
That's okay.
All right.
All right.